Today's video we're going to actually make a foam insert to hold 3 darts. Before we get into this video, if you haven't already subscribed to our channel, please do me a favor and hit the subscribe button. And if you like this video and you want to see more like it, please hit the like button below. Alright, so the first thing we're going to do is we're going to create a new file in VCarve Pro. We're going to make the dart case 4.75 inches by 6 inches by, the foam actually measures 0.8 inches thick. So we're going to set our Z0 to the material surface, and we're going to set our XY datum, which is our starting point that we're going to put the bit at in the lower left corner. The reason I'm using the lower left corner is because I'm going to use a bigger piece of foam so I can position it to like an area on the foam where I want to start, and I know it's going to cut from there. If I was using a smaller piece of foam that was slightly sized closer to what I needed, I would probably use the center. So I'm going to click OK. Okay, so now I'm going to import the photo of the dart that I took a little while ago with my smartphone, and we're going to bring that in. It's a big file. So now the next thing we're going to do here is we have to pick a part of this file. We have to look at this photo, and we've got to measure something on here. And normally I would say measure across here. The problem is there's a slight skew because of the angle that I was holding the phone at. So the best thing to do is probably this barrel right here. So we're going to go over here to the measuring tool, and we are going to select from this edge over to this edge. Now, be careful here because there's a shadow on the table, so we actually just want to pick up that edge. And I could see that I've got a distance of 0.29111. So let's go 0.2911. We're going to write that number down. So the next thing we're going to do is we are going to open up a browser, and we're going to go to stepcraft.us//scale. And this is a scale calculator that I built on our website, so you could use this for scaling up anything. So what we're going to do is we're going to take 0.2911 as our original. Now what we're going to do is grab the dart, and we're actually going to measure that same spot on the actual dart. I get a reading of 0.280. So that's what I'm going to use as my scale 2 number. 0.28 we're going to put in here, and we're going to click calculate. And that's going to give us a scale factor of 96.19. We're going to copy that number. Now what we're going to do is we're going to select the image, and we're going to go over here to set selected object size. And in the percentage, we're just going to copy that number. Now, when we do that, we want to make sure link X and Y is selected so that it scales the entire thing. Okay, so now it's going to slightly scale the image. So now we're going to go here and just double check our measurement again. We're going to zoom in, and we're going to measure from here to here. And I should see that I have 0.28 up in the distance area. Look at right up here, and I've got 0.28. So that's good. Now I know that this image is to scale based on the actual dart size. Next thing we have to do here is we have to draw a vertical guideline on this page. So what we're going to do is just click on the ruler and drag our mouse over, and we're going to stop at 2.375. So it should snap to that because that's the center of the workspace. So now that we have a vertical line, we're going to zoom in a little bit, and we're going to select the image, and I want to move the image. I'm going to use my arrow keys, and basically what I want to do is I want to center the image on this vertical center line on the page. Now the reason I'm doing that is because when I do a trace here, when I trace this, I only want to trace one side, and then I want to be able to flip it. So I don't want to have, it'll save me a lot of time rather than tracing the entire dart, and I'd rather not have to do that. So the only issue that I'm running into is it looks like either the image is skewed slightly or the tip is bent slightly here. So you can see that the tip is not exactly centered. So we're going to have to do our best to kind of compensate with that. So now that we've got a center line drawn, it's just a matter of going over here to the line, the draw line, polyline tool, And what we're going to do is we're just going to start at the bottom, and we're going to start clicking. We'll go ahead, and we're not going to click through a curve. We're going to draw a straight line anywhere that there's a curve. And I'll show you why in a minute. So we're basically just going to click a bunch of straight lines here. We're going to go up here. Now you don't have to go too crazy with every curve. You want to just get things so that it's close. The reason being is we're cutting in foam, so the foam is meant to compress when you put the dart in anyway. So I really am not too concerned about every nuance of the detail on this photo. I'm more concerned with making sure that I've got the vectors that represent the general outline of it. Okay, so there we go. So now we have that. Now the next thing we want to do is on these straight lines here where it should be a curve, we're going to go to Node Edit. We're going to select the line. We're going to put our cursor right over that line and hit the letter B for Bezier. And now we get these two these two lines here that we can manipulate, these hollow boxes. And by dragging those out, you can see that we now can manipulate that vector into a curve. Okay, we'll probably, let's see, I don't really know that I need to do one anywhere else. Straight lines are okay for the rest of this. This right here at the tip. So we're going to do B there. We're going to basically just, again, drag these two out until we've got a curve. Okay, the next thing I want to do is go over here and select the arrow key. And you'll see that now that the vector we just drew is highlighted. And I want to go to Mirror Selected Objects. Make sure that Flip About Job Center and Create Mirrored Copy are both checked. And just click Flip Horizontal. And now you can see that we've basically made a duplicate of that vector on the other side. And as we scroll up, we can see we pretty much have the basic shape of this dart. Okay, so what we're going to do now is I'm going to turn off the bitmap layer, and then I want to go over here and select, hold the shift key and select the other side. So I've got both sides of the vectors selected. I'm going to go over to Join Open Vectors and just click Join. So now both of those vectors are joined together, and it's as if there's one big vector there. Now I've got a couple concerns with this pocket that I'm going to make for this dart. And one of the concerns I have is due to the image and the fact that they're plastic veins, that I'm not 100% sure that I want this to be exactly the size based on the trace. Okay, what I'd prefer is to have this top part for the veins to be slightly wider or bigger all the way around, so that when I push the dart into the foam, it doesn't crush the veins, since the veins are used to make sure the darts are thrown accurately. Okay, but I don't want to scale the entire image. So what I'm going to do is I'm going to go over here to the rectangle tool, and I am going to draw a small rectangle just like that right here. And I'm going to go to the scissor tool, and now what I'm going to do is clip away the some vectors here. So now essentially what I've just done is I've disconnected the veins from the rest of the dart. Okay, so I'm going to select the veins. I'm going to go over to Offset Selected Vectors, and I'm going to go ahead and make sure it's outward. So I want to expand this vector. So I'm going to actually make a copy, and it's going to be roughly 80 thousandths larger. So if I click Offset, you'll see there's my new vector, and it's going to be larger. So now the veins should fit in there perfectly. So I'm going to go ahead and close this. I can select the old vector and delete it because I don't need it, and then go back here to the scissor tool and just clip away these vectors. So now everything is back to one solid vector all the way around. So I'm going to turn the bitmap layer back on and just take a look at what this looks like right now, and I can see that it's slightly larger than the veins. I'm happy with that. What I'm not happy about now is that due to the selection I made, I've got this weird bulge out that I don't need there. So we're going to go ahead and fix that. We're going to click the Node Edit tool, and we're going to select this node, and we're going to delete it. And now we can go ahead and manipulate this. So now I have something that looks very similar to what you see here. Okay, so all I've basically done was eliminated a couple of nodes, got this taper back the way it should be, and now I've got straight edges. So now I'm pretty happy with that. And you can see it's slightly larger than the veins, which I'm fine with. That's exactly what I'm looking for. Okay, so that's how we deal with making the pocket slightly larger on part of the vector. So again, I didn't want to make the whole vector larger, just the top veins. Okay, the next thing I need to do here, I'm going to go ahead and hide the image, is I'm using an 1/8 inch end mill. So I'm going to go to the circle tool, and I'm going to set my diameter to 0.125, and I'm going to draw a circle right here. Now this is going to tell me quite a bit, because what's going to happen is the end mill, Vectric is not going to let a tool path go based on the end mill diameter anywhere in the vectors that it won't fit. Okay, so I'll show you this right now. If I select this dart vector and I go over here to pocket tool path and I go ahead and calculate it, you'll see that it is not getting into this area and it's not getting all the way down to where the tip of the dart is. Okay, so we need to fix that. So by zooming in, I'm going to take the circle and I'm going to move it around and see. So I know I'm okay here, I'm okay here, and just about here is where it starts to be a problem. So what we're going to do is go to node edit mode. We're just going to move a couple of node points around, these two here. I'm going to move this one slightly out. I'm going to move this one slightly out. So now my end mill will fit right here. Now obviously this is tapered, so the further down I go, it starts to get tight again. Like right here, it won't fit. So what I'm going to need to do is go to node edit mode again, and I'm going to move these two nodes out a little bit. So now if I bring my end mill circle here in, you'll see now it fits all the way through. Okay, so now if I rerun this pocket tool path and I preview it, see now it goes all the way through that center. So now I just want to double check the tip of the dart, and then we'll be ready to create some tool paths. So I'm going to zoom out, I'm going to select this circle and bring it down here. We'll zoom back in. Okay, so yeah, just as I suspected. So it looks like the Vectric is probably allowing the end mill to go as far as, I want to say, right about here. Okay, so I got to make sure it gets down all the way to the bottom. So what I'm going to do is, now I know this is the circle diameter. So I'm going to go back to node edit. I'm going to click on these nodes here, and I'm going to move this one out a little, and move this one out a little, and I'm going to move this one down a little. Now I'm going to have to do a little manipulation here just to make sure it stays round, you know, looking round, which I kind of like the way that looks. Okay, so now I'm all set, because now I know my end mill will get all the way down. I'm not going to have any issues. Okay, so that's a little trick for you when you want to test something out when you're designing, to make sure that your end mill is going to actually fit in certain vectors. So now when I go ahead and I click pocket, you can see now the toolpath is extended quite a bit from where it was. See, it stopped there before, but now it's going all the way down. So when I go ahead and I preview this, now it goes down a little further. Okay, so that's going to work out perfectly. I have the one vector all done. A dart set is typically 3, so I'm going to want to go ahead and make 3 of these darts on this one insert that I'm doing. Now what I'm going to do is take this dart and I'm going to invert it, because I want to have three darts here on one piece of foam. So I'm going to have the one on the left and the one on the right are going to be in this orientation, and the one in the center is going to be upside down. And the reason I'm doing that is so I can put them closer together and I don't have to use as much material. Now I don't have an insert yet for this, so it's not like I have a case that it's going to go into. I might make one out of wood with a hinge as a separate project. But for right now, I'm going to try to make it as small as I possibly can without wasting a lot of material. So if I select this vector and I go over here to rotate object. I'm just going to rotate it 180 degrees and hit apply. So now it's upside down. Now I'm going to go ahead and make a copy of it. And I'm just going to use my arrow keys and move the copy over. Now on that copy, I'm going to do the same thing. I'm going to rotate that back. So now it's the other way. Now what I want to do is, using my arrow keys, I want to move this in until it's far away from the center one as I want it to be, and I'm happy with the alignment. Now as soon as I am, all I need to do is make sure this one's highlighted, go over here to mirror selected objects, flip about job center, and create mirrored copy need to be checked, and click flip horizontal. Okay, so now I have the layout I want. I've got one on either side and then one upside down in the middle. So now I'm all set to go ahead and do my tool pass. So to do the tool pass on this, it's pretty straightforward. I already showed you a dart pocket before when I was trying to give you a preview. I'm going to use the same tool path here, but what I want to do is go ahead and highlight. I want to drag my mouse over so I'm highlighted and selected all of the all three darts, and that way whatever I apply here is gonna happen to all of them. So I need to go down 0.65 inches from the top surface of the foam, and I measured my dart height, so that's how I came up with that number. I'm using Amana Tool 46564 1/8 inch foam cutting end mill. It's a down spiral end mill, which is very important when cutting foam. If you want to ensure that you have a nice crisp top edge, you need to use a down spiral end mill. If you use an up spiral, it's going to fray at the top, and you're not going to be happy with the results. So we're going to use this down spiral end mill. It's going to give me a really nice finish. What I want to do here is I'm going to click edit and look at my speeds and feeds for this particular end mill. So what I'm using, the rule of thumb I'm using for foam is I can go 2 times the diameter of the end mill. So my end mill is an 1/8 inch. I'm going for a pass depth of 0.25. All right, so twice the diameter. Now, if I was doing softwood, I would go 1 times the diameter. If I was doing really hardwood or metal, I might go half of the diameter. But in foam, because it's a very low load material, and it's really soft, the end mill is going to move through nicely. I'm comfortable with going 2 times. I can go more than that. I could probably cut this entire thing in one pass, but what I'm concerned about are the small little peels that you get, like the kind of the equivalent of chips with foam. And if I go ahead and I try to cut too deep, then there's a chance those peels will wrap around the end mill, and then that'll go ahead and cause like a burning effect on the edges, and I don't want that. So to try to avoid it, I keep my pass depth at no more than 2 times the diameter. That creates smaller peels, and then I always keep the dust collection system on, so it kind of, when they break free, it draws them away from the end mill. Okay, so we're going to use pass depth to 0.25. I have a step over, which is pretty standard default at 40%. I'm using a spindle speed here of 15,000 RPM, a feed rate of 120 inches per minute, and a plunge rate of 90 inches per minute. Now, you might be asking, where did I get these numbers from? So what we're going to do here real quick is we're going to pop over to Amana's website. And if you do a search up top and you search for 46564, that's going to bring up this end mill. Okay. If you go down the page a little bit, you're going to see a button that says speed and feed rate, and there's going to be a PDF document here. Go ahead and click that. This document is going to give you their recommendations for this particular end mill. Now, I don't know what they base these on. I don't know what type of CNC they base it on or anything like that. I do find that a lot of the Amana documents are based around 18,000 RPM. That's the max speed of the spindle I'm using on this machine. So I usually don't like to run at the max speed. I don't know that it's even necessary when cutting foam to be running that high in RPM. So I'm actually lowering that down to 15,000. Now, mind you, I ran some tests prior to making this video, and I tried even lower, and I tried 18, and I found 15 gave me a really good cut result, okay? The depth of cut they're saying is 1 times the tool diameter. Now, you can reduce the chip load by up to 3 times if you want to go 1, 2, or 3 times the diameter of the, but because Vectric doesn't really deal with chip load as part of their toolpath calculation, I'm not even going to really get into that right now. I'm using, again, because I ran some tests, I'm going twice the diameter of the cut. What I am concerned about here is what they're specifying for the feed rate. So they're saying between 100 and 140 inches per minute. Now, I'm not sure where they get this from. I mean, 100 inches per minute may be what they're recommending for somebody that has a you know, kind of a weaker machine or belt drive machine, a DIY machine or whatever, and 140 might be more to the industrial side. It also probably has something to do with the depth of cut, because if your chip load goes down, your feed rate is going to go down as well. So I usually, whenever I see a range like this, I pretty much like to get right in the middle, and that's where I start. So that's where I came up with the 120. So that's basically where I got the speeds and feeds that I'm using. So it was kind of starting with what they have here and then kind of modifying it a little bit based on the results I was getting on my particular machine. And so that's what I am using here for this particular speed and feed setting. Okay, so I don't want to close that. Okay, so that's my settings for there. I am going to use an offset toolpath. So basically, I don't want to go back and forth with the end mill. I don't want to go up and down. Those are really inefficient toolpaths for something with a shape like this. So by going to an offset toolpath, now what's going to happen is the end mill is going to go ahead and pocket this out, and it's going to keep going, kind of following the vector in that general shape. It's the most efficient toolpath to use for a shape like this. Now, the most important thing you need to know when cutting foam with this particular end mill is you need to make sure you're in conventional cut direction. If you have climb selected, the walls of everything you cut are going to look like the foam is torn. It's really, really a bad looking result. So you want to make sure that you're in conventional, and your finish is going to be excellent, especially with this particular end mill. Now, I have no reason to ramp here because we're going foam and we're only going down a 1/4 inch at a time, so I have no problem doing a straight plunge. And we're going to go ahead and calculate this toolpath now, and I'm just going to call it Dart Pocket and click Calculate. Now I'm going to reset my preview, and I'm going to go ahead and click Preview the selected toolpath. And there we have it. This is what the foam insert's going to look like with the 3 darts in it. What's nice here is you're able with Vectric to change the type of material. So if I was doing this in wood, I can change it here. In this particular case, my foam is red, so I went and said use solid color and selected red from this box. Now I could, if it was blue, I could choose blue. It's nice. It gives you the ability to see what your finished product is going to look like prior to actually cutting it, and it gives you a really good idea. Now I chose a global fill color of black simply to give me contrast, so I could see the black bottom here versus the red foam. Now obviously when I cut this for real, it's going to look like this because it's red foam all the way through. All right. So the other thing I got to do is, because I don't have a case or anything to put this in yet, I don't have a final vector shape for the cutout. So what I might do is make a box out of wood or and hinge it or something to put these darts in later. But for the purpose of this video, what I'm going to do is go ahead and I'm going to create a box that goes around here. And let's just round these numbers off to 4.5 by 5.75. We're going to do a radius external, and we're going to do a 1/2 inch radius on that and click apply. So now you can see you've got a nice vector outline around with rounded corners. So with that vector selected, I want to make sure it's centered in the work material. So I'm going to click Align to Material, Center in both directions. Now I need to create a profile toolpath for that. So I'm going to go over here to Profile Toolpath. I'm going to make sure the same bit is selected. I know my foam is 0.8 inches thick. I like to go 10 thousandths, usually 10 to 20 thousandths, depending on what I'm cutting, deeper. So I'll cut into my spoil board very, very slightly. Because I'm using an MDF spoil board, I don't want the MDF dust to mix in with the foam. So I'm only going to go 10 thousandths below, and that'll ensure I got a nice bottom cut, and then I'm cutting all the way through clean. Again, I have the same Amana tool chosen. This is actually giving me 4 passes because I'm cutting deeper, and again, I'm fine with that. I'm going to leave that alone. I'm cutting outside the vector because this vector represents the finished shape. If I was cutting inside, then my job would be smaller, it'd be an 1/8 inch smaller all the way around. So I want to make sure the outside is selected. Again, make sure conventional is selected. The other thing I'm going to do here is what they call do a separate last pass. I want to make sure that's checked. Now what's going to happen is when you're doing 4 passes through foam, every time it steps down, you're going to see a fine horizontal line on the edge of the foam. And that's simply because the bit is spinning, it's compressing the foam slightly, and then it expands after the bit goes by, and you're going to end up with these lines. So if you don't want to see those lines and you want a nice clean edge cut, then go ahead and do separate last pass. I usually set the allowance to 10 thousandths, and what that's basically going to do is for the first 3 cuts, the end mill is going to be 10 thousandths away from this vector. So your project will actually be 10 thousandths larger all the way around. But when it does the very last cut, it's going to move in 10 thousandths, and that way, as it goes around to cut the bottom, the flutes of the end mill are actually going to take 10 thousandths of material all the way off the entire thickness of the edge of your material, and that'll remove any of the line marks that you have in the side. So the only thing you got to be careful of when you're doing that is you need to make sure that your end mill has a cut height that is greater than or equal to the material thickness. So if you had, in this case, I need to go a cut depth of 0.81, but if my cut height on my tool was only 0.75, then I couldn't use it, because what would happen is the shank of the end mill would start to rub against my material, and you won't want that. So this is a great thing you can add to your project to get a better sidewall. You just have to make sure that the cut height of your end mill is equal to or larger than that of your material or your cut depth. I'm not going to use tabs because I'm double side taping the foam to my spoil board, so I don't have to worry about that. I am going to add a ramp, with a smooth ramp with a distance of 1 inch, and the reason I'm doing that is I want to gradually enter the foam as I'm doing the profile cut. What I worry about on foam sometimes, if I plunge straight down to do a profile cut, what I don't want to have happen is I don't want to see a rounded indication of, oh, that's where I started on this. And I find that sometimes that happens. I don't know if it's the heat of the end mill that does it. It could be the foam expanding or contracting. But I find that if I do a ramp, I never have that on the edge. So I'm not using a ramp on the pocket because I'm clearing and removing material. But when I do a profile cut, I like to add a ramp to it of about 1 inch. I think that's fine. We're just going to call this cutout, and then we're going to click calculate. It's warning me that my material thickness is 0.8, but I'm actually telling it to go down 0.81. So it wants to make sure that I have a spoil board so I don't cut into my machine bed table. So that's really important when this pops up. Please pay attention to that. So I'm going to click OK, and now I'm going to do preview selected toolpath, and there's going to be my final product that I'm making. If I double click on these corners, the waste material goes away, and I'm left with the finished item. Okay, so that's what I'm hoping to see on my CNC when I'm done, and we're going to save this file out and go run it, and I'll show you some video of that right now.